How are you guys?
I'm fine. How about you?
Good, what about you?
I'm okay. Super busy, but good. I'm trying to enjoy every moment. There is no reason to be sad and a little bit tired. Also, it's okay. Anyway, uh, I have very tight schedule. Only these 2 weeks. After that, I'll have more free time, and I hope I will enjoy my time more. So I hope you all had also a nice weekend. And if you ask me, I had a great weekend. I went somewhere with my family and we had a picnic. I missed trees and lakes and river a lot. And we had a lot of fun activities. Good. Okay. So Musa, Daphne, Sona, are you ready for class or?
Yeah.
Yeah.
And let's continue practicing some more questions. And as we practice more and more, you get more ideas. And after that, maybe I will ask you to try some questions and let's see how it goes. Okay. As you know, actually now we actually give some kind of break to our learning, not learning, and we are not working on a specific topic. Now we are practicing Sasmo problems. And also in this kind of questions actually teach you a lot of things. And at least it actually, how to say, changed our thinking skill. So we started from this, right, 2014 S1. After we finish this, then we will practice S2. If you ever compare these papers, a lot of questions, especially logical questions, or that require the general logic questions, are very similar. Okay, a little bit, there's a slight difference, but very similar. That means that if you understand the question in S1, you can also actually understand the question in S2 or S3 easily. Okay, now let's continue. All right, we did this questions, question one, question two, question three, question four, question five, question six, seven, eight, nine, 10, and we finished this. Yes. Oh, we stopped here. Daphne, did you try this question?
Which this one?
Question 10. Oh,
Yeah, no.
what did you get?
I didn't try it, teacher. There's probably like an answer to it.
Okay. So it says that the first number is 6. The question is, what is the next number, right? So the next number is, anyway, until 24, we tried this. We didn't get anything. And 25, it doesn't work. Also 26, it has only 3. It doesn't work. 27 also, like 27, the factors are 1, 3, 9, and 27, except 27. The sum is not 27. How about 28? It is 1, 2, 4, 7, 14, and 27 and 28. The sum is 1 plus 2 plus 4 plus 7 plus 14. That's equal to 3, 7, 14. What? Okay, that's 28. So that is the second number then. What's the question? Perfect, because 1, 2, and 3 are the only proper positive factors of 6. Find the next perfect number. So the next perfect number is 28. Okay. Uh, the one way is from here, we need to just actually, how to say, remove the prime numbers. All right. We don't have the prime number because if you just take any prime number, it's not a perfect number. And after that, we should just try some numbers. Also, actually, odd numbers. I don't know. Also, it doesn't work. Anyway, I think if there are any general methods that I have to think about this, but I don't think there's any general method. With a single formula, we cannot get this. The only way is just calculate fast and we can get the other numbers. And if there's any formula, let me have a look again. I also forgot about this question. And after that, maybe we can discuss later if we have any similar question. Anyway, guys, let's move to the next question. Let's solve maybe 3 4 questions together. After that, I may ask you to give it a try.
But teacher, that question like says the next one. It does not say like find the perfect numbers till something. So it's a lot easier. Just try to find it till it becomes
Yeah,
like you
that's
won't
right.
go up to 100. That's what I'm saying.
Yeah, that's right. It is easy. Just you need to try some numbers, and after that, the first one we get, that's the answer. Usually, definitely, actually, this Sasmo, it is not very difficult math Olympiad. Actually, this is for the students who are good in math at school. Okay, and the goal is, and also because if you are smart or hardworking or good in a subject, just studying well in math, it may not be uh, satisfactory for you. Okay, but sometimes you want to prove yourself. All right, but if you just participate in this Olympiad, I mean this kind of thing, which is accepted by a lot of countries, and you're just proving yourself. Look, this guy is really hardworking, or he knows well, or she knows well, and that's a proof. Okay, because sometimes you may be very good in something, but until you prove this, people may not accept this. So that is not too hard. It is not so easy, but just fast calculation. I mean, what you have to do at school, what actual skills are required to study well. I mean, to study math well at school. That is just a little bit higher standard of those topics, and it's really good because international math Olympiad questions usually they are very hard, but this one everybody, if they just try a little bit, they can do, and they can understand easily. Anyway, so what I mean here, Daphne, if we are calculating and if it is taking very long, that means that we are using wrong methods. That's what I understand, because here there are 25 questions and you are given only 100 minutes on average for each question. What is it? Like around 4 minutes. All right. That means that they cannot ask a question that takes a long calculation. Okay. So the next question is the dimensions of a rectangle. Dimensions of a rectangle, that means that we are talking about length and width, are x centimeters by y centimeters. Okay, we are talking about some kind of rectangle. Let's draw this. And the length is x, let's say y, width is y, where x, y are integers. That means that x and y, they are integers. Integer means positive integers, right? That is just simply natural numbers, 1, 2, 3, 4, 5, 6, such that the area and perimeter of the rectangle are numerically equal. Numerically equal means we are not talking about its dimension, I mean its unit, because when you find the area, for example, what is it? The unit of the area is square centimeters. And how about the unit of perimeter? It is centimeter. But if you just actually ignore the units, right? So we are just talking about the numerical part. Anyway, it says that such that the area and perimeter of the rectangle are numerically equal. Find all the possible values of x and y. So what does it mean? We know that the perimeter of this rectangle is P is equal to 2 times x plus y. And how about the area? Area is equal to x times y, right? What are these things? What are x and y? So again, we can actually how to say, get the general formula, but instead of this, what we know here is x and y are natural numbers. That's a 1, 2, 3, 4. We can just actually try some numbers. For example, let's say uh, let's say if x equals 1, can it be 1 or not? The perimeter is equal to 2 times y plus 1, right? It is even. How about area? Area is equal to just y. If they are equal, then they should be equal to each other, right? 2y plus 2 is equal to y. From here, y is equal to 2. What? 2y plus 2 is equal to y. Y is equal to minus 2. 2 equals minus 2, right? So it doesn't work because this also y should be positive number. So x cannot be equal to 1. And how about if x equals 2, for example? Let's say if it is 2, the perimeter is again 2 times y plus 2. And how about area? Area equals 2 times y. Now, if you substitute here, 2y plus 4 is equal to 2y, and 0 equals 4. Also, actually, this x cannot be equal to 2, right? 2 plus y, 2y plus 4, 2 times y. And how about if x equals 3? If x equals 3, perimeter is equal to 2 times y plus 3, and the area is equal to 3 times y. From here, 2y plus 6 is equal to 3y. So y is equal to 6. It works. Now we got one answer. So let me just write here. Our answer is x equals 3 and y is equal to 6, right? And what is 3 times 6? It is 18. And 3 plus 6 is 9. And 2 times 9 is 18. Okay. And how about if x equals 4? One more step. If x equals 4, for example, here we have p will be equal to 2 times y plus 4, and area is equal to 4 times y, right? Now from here, 2y plus 8 is equal to 4y, and y is equal to 2, right? It is y is equal to 4. So if it is 4, and also y is equal to 4, we have another answer. So here we have x equals 4 and y is equal to 4. In general way, actually, we can solve this, but here, that's just one guess and trial method. And let me just continue here. Now we will see that if x equals 5, for example, the perimeter becomes 2 times y plus 5, and the area is 5 times y. So from here, 2y plus 10 is equal to 5y. What is 3y? Is equal to 10. Y is equal to 10 over 3. Right. Now, if you just continue this one, actually, we will not have any whole number. Okay. I mean, this y will not be a whole number. Any different idea, Musa, Defna, Sona?
No.
We have only two possible rectangle like this. It is 3, 6, and the 4, 4.
No, maybe it's
Oh, yeah. Teacher, can we consider minus numbers?
infinitive.
Can you
No,
what?
like consider minus numbers. No, like minus 2, minus 3.
No, we don't use negative numbers for length, right? That's why only should be
But
positive.
teacher, it's about like the place that they're in. So like if you use my negative numbers, then it will just be on the other side, like just the symmetric of it.
Yeah, in general, if they say it's okay, but here we are talking about the dimension of a rectangle, right? We do not use negative numbers to measure the length.
Yes.
So
Okay.
that means it must be positive only. Anyway, guys, for now, that much is enough. Next time in S2, we have also similar question. At that time, we will just consider the general case. In general way, how to solve this. Okay, now actually just knowing this method, the method is enough for now. Let's move to another question. After that, you will try the next question. If A and B are positive whole numbers, okay, we know what we mean whole number. It is 0, 1, 2, 3, 4, 5. And actually, it says positive, so it is 1, 2, 3, 4, 5, 6. Anyway, such that here, what is given here? A is less than B. Okay, and also a to the power of b is equal to b to the power of a. Find a possible value for a and for b. Okay, so again, if we don't have the first condition, immediately the first thing comes to our mind is it's 1, right? 1 to the power of 1 equals 1 to the power of 1. And the second solution is 2, right? 2 to the power of 2 is equal to 2 to the power of 2. And the third one is maybe 2 to the power of 4. For example, one answer is 2 to the power of 4 is equal to 4 to the power of 2. That's also another solution. Okay. But how about in general, again, how do you solve this? Since A is smaller or less than B, right? And A and B are positive whole numbers, let me just try with one. Number one is if A equals 1, what happens here? If A equals 1, now we are looking B, which is greater than 1. If you substitute here, 1 to the power of B is equal to B to the power of 1. So what is it here? 1 to the power of b is just 1. B to the power of 1 is b. So b is equal to 1. But actually 1 is equal to 1. So this cannot be the answer. Because in the condition, a should be less than b. They cannot be equal to each other. Right? And the second one is, how about if a is equal to 2? If a is equal to 2, here we have 2 to the power of b is equal to b to the power, b squared. Right? So now from here, uh, and also b should be greater than 1, greater than 2. So if b equals 3, it doesn't work. If b equals 4, it works, right? So from here, b is equal to 4. Now we got one answer. So that is a is equal to 2, b is equal to 4. Now that is our answer. And we continue. How about if a equals 3? If a equals 3, here we have 3 to the power of b equals, and here we have b cubed, right? And now we know that b is 3 to the power of b and b cubed, and this b is greater than a, right? So now if you just substitute anything, for example, if it is 4, let's say 3 to the power of 4, let's say b, if b equals 4, here we have 4 cubed, right? Or 3 to the power of 5, and here we have 5 uh, okay. Now what is it? 3, if b equals greater, it should be greater than 3. So if it is 4, here we have 4 cubed, right? 3 to the power of 4, it is 81. And this one is, what is it, 64. And if you just put, again, a little bit bigger number here, and this one is not changing, right? The power is changing. If b is greater than 3, this 3 to the power of b is always greater than b to the power of 3. Okay, they cannot be equal to each other. Why? Because here in the power we have b, and here the base is b. Okay, so whatever you substitute that is greater than 3, and 3 to the power of b always greater than b to the power of 3. That means that after 3 we cannot get any answer. So the answer is only we have one solution. A is equal to 2, b is equal to 4. Okay, Musa, did you understand?
Yeah, it's easy.
All right. Find the value of this. I mean, solving this kind of questions, I think you are so good. We practice a lot of questions, but let's do this one more time. Here we have 1 over 1 plus 2 over something. Again, 1 over 1 plus 2 times something. So if I just denote this one by x, what we have here? Here we have 1 over 1 plus 2 times an x, right? That is equal to x. Now from here, if you multiply both sides by 1 plus 2x, here we have 2x squared plus x, and take 1 to the right hand side, minus 1 is equal to 0. Now we got quadratic equation. We know how to solve quadratic equation. Let's try first by factorization. This one is 2x and x. How about this one? It is negative 1 and 1. If you cross multiply, it is negative x plus 2x, that's equal to x. So we can factorize it as 2x minus 1 and here we have x plus 1 is equal to 0. So either x equals 1 over 2 or x equals negative 1. But here 1 is divided by positive number, right? So x actually, this cannot be equal to negative. So this answer is rejected. What is our answer? Our answer is 1 over 2. So the whole thing is equal to 1 over 2. Okay, find the last digit of 2014 and 2014. Guys, can you give a try to this question? Let me give you 2.5 minutes. And after that, we will discuss together and solve it together. Give a try, 2.5 minutes. How would you solve this question?
I found the answer.
What is it?
6.
6. How about you, Daphna? Sona? Daphna? Did you get it?
No, not yet, teacher.
Why not?
Teacher, I am still busy calculating.
Okay, calculating what? There's nothing to calculate here.
Why?
Yeah, because here it says just the last digit, right? So here the last digit means we are talking
But
about.
teacher, you have to either find if it's like 6 or 4.
Okay, so if you just write here 1 to the power of 4, the last digit is 4. And 4 squared, the last digit is 6. Again,
Yes.
4 cubed, 4 times 6, again last digit is 4. And 4 to the power of 4, 4 times 4, 6. That means that if the power is odd, the last digit is 4. If it is even, the last digit is 6. But here the power is even, right? So the last digit of this number is 6. So dot, 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 it is 6. That's it.
Yes, teacher.
Good. All right, the beautiful question. I don't know how can we solve this, but have a look. Okay, try to do this. Let's see. The diagram shows 9 points. Draw 4 consecutive line segments. In example, the start point of the next segment must coincide with the end point of the previous segment to pass through all the 9 points. Daphne, did you ever see this problem before?
This kind of problem.
Yeah,
Yes.
it's called 9 dot problem.
Not the specific one, but similar ones.
Because the one guy, I forgot his name, is a famous actor in Hollywood. When he's giving a speech, actually, he gives this example. And if you really want to draw lines here, 9 dot, if you want to actually pass through all these points, you need to get out of this square or these dots. The only way. It's like thinking out of box. Anyway, let's try this and we will discuss this later. Let me also try draw 4 consecutive line segments. Okay. So the start point of the next segment must coincide with the end point of the previous segment to pass through all the 9 points.
It's umbrella.
Hmm?
It's something like umbrella. Yes, it
Yeah,
looks like, yeah.
that's right. It's also a nice question, but of course, we are discussing here, but if it is asked in the exam time, you have only a few minutes, right? And it's not so easy. Of course, it
Did you
depends
know
on how.
actually it's very easy. I mean, in Turkish test, the one that I entered like this Olympiad, you have to like sort of study, how do you call it? Visual math, like this kinds of stuff. So there's like a certain, how do I put it? Um, Sort of like this way to solve it, even if it's like, I don't know, 2000 dots there. There's like a way to do it.
Hmm. Yeah, actually, again, Daphne, once again, this kind of questions, when you just solve this, I don't know, actually, I had to look at a lot of questions, what kind of questions they ask. It is really to introduce students with this kind of problems, okay? It's not something very hard. Now, if you just search even on the internet, you can find this. Even a lot of speakers, they use this in the speech, okay? And this is actually S1. S1 means grade 7 students, right? So we are just practicing this. So, and also another purpose is to introduce students with this kind of beautiful problems. Okay. Anyway, the idea here is to join this one. The only way is we need to get out of this box, right? Otherwise, it's not possible. So how do you do that? Maybe do I do it like this, right? And after that, maybe continue from here and the third line, and after the fourth line. right? It is something like this. So now we have 4 line segments, starting from here, number 1, and the say endpoint, and continue here, the second number line, and continue here, and continue here. As you see here, we just pass through all the points, and also in the condition, the start point of the next segment must coincide with the endpoint of the previous segment. That means that again, we have to join these points without lifting our pen off the paper. Okay, and you are allowed to draw only 4 line segments. There's some other questions. Maybe if I just find them, I share with you later. Okay, guys, let's continue. Next question. What are the last 5 digits of the sum? That's also another beautiful problem. Can you have a look and think about this? What are the last 5 digits of the sum? Musa, Defna, Sona, Ibrahim, are you there?
Yes.
Yeah.
Yes.
Defna, did you get anything?
Yes.
What did you get?
Should I say them in order? Like,
Yeah, just tell me.
it's just the last 5
1,
digits.
2, 3, 4, 5. What are the last digits?
I found it as 0.
0?
Yes. No,
How is it
not
possible?
all of them. Like the one at the last is 0.
Really?
Yes.
Okay, but it's wrong. Let me just write 0 here.
I
The previous
know
one?
it's wrong. Wait, will it be like 9? No.
No. The last digit is 4.
How?
Okay, guys, let's do this together. Look here. This is just secondary one. It cannot be very complicated. Now, if I just write these numbers, how many here we have? We are talking about the sum of 2014 digits. Maybe this year you can just write them here. Maybe 2021 digit number. Okay, usually this is how they prepare questions. Now, look at this. If I just write here, the first I write here 1, right? The second 11 is 11 here. And the third one is 1, 1, 1. Fourth one is 1, 1, 1, 1. Fifth one is 1, 1, 1, 1, 1. Dot, dot, dot. Continue. Let me just write here 1, 1, 1, 1, 1. Okay, we have to find this sum. All right. So now how do we add this? Just simple addition, right? If you just add the first unit digits, how many ones do we have? Since here we have 2014 numbers, here we have 2014, right? So this one is 2014. So what is 2014 plus 2014 ones? It is just 2014. So what we write here, I just write here the last digit, right? 4. Now I just keep 2010 here, right? Because I just write 4. Now if you just add the second column, and how many ones do we have in the second column? It is one less than before, right? Because now we are just adding starting from 11. So here we have 2013, one less than 2014. So now here we have 2013. If you add this, it is 4023. So the last digit is 3. So here we have a 3. In the previous one, now we have 2012. So now here we have 2012. Now here we have 4020 and 2012. So that is 2. So this should be 2. Now in the previous one, we have 2011, right? So 2011, again, here we have 6,000 something, 6,030 and 2,000, okay, 14, 13, 12, 11, right? So the last one is 4, 1. So here this one will be 1, right? And how about the previous one? The previous one here, how much do we have? Now again, here we have 8041. Already we wrote 1 there, right? In the previous one, now we have how many? It is 4, 3, 2, 1. Now here we have 2010. 2010, if you just add here 2010, right? It is 0, 0. So this will be 0. So that is the last 5 digits are 0, 1, 2, 3, 4. Musa, did you understand? Defna, is it clear? So easy question.
I don't. I don't know.
Yes, teachers.
Musa, what you don't know?
I don't know. It's hard.
No, but did you understand the solution? How we solve this?
No.
Really? Musa, here you just add, for example, if you just pick 3 number, for example, if you add, how do you add this? We just write here 1 plus 11 plus 1, 1, 1, right? And after that, you just add this. 1 plus 1 plus 1, it is 3. 1 plus 1, it is 2. And here we have 1. Right? But now here, how many numbers do we have here? Here we have 2014 numbers. So now I just write the first one. The first one is 1. Second one is 11. Right? This is the second one. Third one is 111. Fourth one is 1111, and blah, blah, blah. And how do we add numbers? You should start from the rightmost side. What is it? Right hand side of these numbers, right? In the first column, how many ones do we have? 2014. In the second column, we have 2013, one less. In the third column, 2012 ones. In the previous one, 2011. In the previous one, 2010. Why? As you see here in the first line, 1. The second one, 2. In the third one, 3. If you just take the column wise, the first column, 3 ones. Second column, 2 ones, 1 less than the before, right? Third one, it is just 1. Okay, Musa, just you need to think a little bit maybe. It's so easy question. Let's move to the next question.
Okay.
We will practice similar question again later, okay? All right, what is the least number of cuts required to cut 10 identical sausages so that they can be shared equally among 18 people? That's also a beautiful question. Can you try, okay, first, and after we will discuss. You have 2.5 minutes to think. Time starts now. Any answer?
10.
Definitely. Come on, this is so beautiful question. Sona, why are you so quiet?
I don't know.
So you don't know why you are so quiet. Really?
Yeah, I guess I don't have anything to say.
Here.
Ibrahim,
No.
how about you?
Did I got 0?
Zero.
Yes.
If it is zero, how can we share 10 sausages equally among 18 people? How?
10 cats.
Don't need to cut the sausages. You can just bite them and then give it to the other person. Oh
Yeah.
my god, I'm being ridiculous.
Musa, did you get any answer?
10.
10. Is it possible?
Yeah, like the sausage and you half of them like there, like something like this. Not like this, like this. And there's two remains, two slices of sausage remains.
Okay. I don't know. Actually, I got 26. So if I'm not wrong, you have to correct me. What I think is we have 10 sausages, right? It says that what is the least number of cuts required to cut 10 identical sausages so that they can be shared equally among 18 people. Okay. So suppose that each sausage, for example, let's say this one is our sausage. Okay. This is angle one. And if I cut from here, number one, and if I cut here, number two, how many cuts? Two cuts. And how many sauces do we have? 10. So here now we have 10. Each one is two cuts. Here we have two. Now I already made 20 cuts, right? But now how many sauces do we have here? Here we have 30 pieces, okay? 30 pieces of sausage. Now I can distribute this like this, maybe 18 and plus 12, okay? So now again, I'm going to cut this one, okay? So this one, now actually each one gets this 18 pieces plus this 12, I can write it like this, the 6 and the plus 6. Again, if I just cut this into, for example, here we have 6, right? Cut into 2, for example, here, again, cut into this to 6, right? Each sausage divided into 2 half. Now here we have 12 pieces. Now here we have every 6 pieces, right? Plus 12 pieces. How many cuts? 20 cuts. Okay, here we have 20 cuts in the first one, plus in the second one, and here we have 12 cuts, 12, 6 cuts. So altogether it is 26 cuts. All right. Okay. It is 6 divided by 3. Okay. Then maybe if you just take this as a kind of number here, 18, all right, 12, 26. Okay. Did I make a mistake here? First, if you cut this like 10 cuts, I mean, each one is 2 cuts, 20 cuts. Now here we have 30 pieces. So you just give one piece to 18 people. Now 12 pieces left. Again, now I have to cut these 12 pieces so that we can actually share equally, right, among these 18 people. To do this one, 12, right, if I just cut each one by 3, now we will have 36. Each one gets 2 smaller pieces. So it is 12, 24, and 24 plus 20, 44. Yes, Defna, Sona, Ibrahim, Musa, can you find a smaller number?
No.
But
Okay.
I saw it's 10.
10? It's not possible. Yeah, how come?
Like you have this sausage and like you cut them like this, and then it's made like 20 sausages, and the two remains, and two remains you can throw or give to some homeless.
Teacher, the thing is like you have to sort of find where they like sort of match. Should I say? It's
Yes.
not that hard. You just have to give some time and like really focus on it. Not that hard.
Okay. 1, 2, 4, 40, 3, 6, 60, 9 pieces. 1. Okay. But I'm just because thinking like, suppose that we are given one sausage like this. If I cut from here, now we have 10 cuts, right? Plus, now I cut from each sausage like this. Now here we have another 10 cuts because we have 10 sausages here. Now again, I cut from here. I have 10 cuts here. Altogether, how many cuts? It is 30 cuts. Now each actual sausage I divided into how many pieces? 1, 2, 3, 4, 5, 6, right? So 6, it should be 9 because it's not divisible by 18. Anyway, oh, I think I'm so tired. All right, it's so beautiful question, guys. Can you try Defna, Musa, Sona, and let's discuss this again, okay? What I got here is, actually, I try to get, for example, 10, right? So just by cutting this, can we just divide this into, what is it, by 18 people, each one gets the same amount of sausage, right? So this one is the first, if you cut this into 10 cuts, we have 30. First, now I will give them like 1 pieces each, okay? 10 cuts, not 20, not 10 cuts, 20 cuts. When you just said 20 cuts here, let me from here, okay? Now 20 cuts. Now how many we have here? 30 pieces. So I already give them 18 people equally. Now here we have 12 pieces left. Now 12 pieces, right? Again, if I just, now here we have the smaller piece. Again, 12 pieces, right? If I cut from here, here we have 12 cuts. And again, here we have 24 cuts. So 24 plus 20, right? That is 44 cuts. That's my answer. But let's see if we can find smaller than this or not. Okay. Anyway, and let's just 18, 19, and 20. Let's just do it until 20, okay? And then we'll finish the class. Divide the following shape into 4 identical parts. Okay, and also you can do this here. What is it? If you just look at this figure, now whatever it is, like for example, maybe if I divide from here and right here, I can see that it is 3 squares, right? How can we divide it into 4 parts? If this 3 square here, let's say each side is A, here we have A times A. If I divide this by 4, so suppose that this one side of this square is 4. This one is 4, this one is 4, this one is 4, and this one is 4, this one is 4, right? So the area it is 16, 16, 16. That's equal to 48. Now, if I divide this by 4, then each piece has the area of 12. How can I do that? Again, here, if I just divide this into 4, and also this one into 4, and also this one into 4, right? To get this 12, maybe I can just draw now with blue, so that I can just divide from here, because each area must have 12 centimeters square, right? And the second one, 12, again, here we will have maybe uh, this one, right? The second one. And third one is this one, right? And the last one is this one, okay? So this is part A, this one is part B, part C, and part D. All of the shapes are identical. Using just geometry, you can just assume that the area of this one is something. If you divide by 4, again, so there's those divided figures must be identical. That means that they have the same area. And after that, you can get the answer. Anyway, solve the following equation. Here we have x to the power of 5 to x cubed. And usually with formula, solving this kind of equation is hard. The best way is we have to try factorization, right? Now from here, the common factor is x cubed. So here we have x squared plus 2, and the minus, here we have x squared plus 2 is equal to 0. Now x squared plus 2 is a common factor, and here we have x cubed minus 1 is equal to 0. And we know that x squared is non-negative, plus 2, it is always greater than or equal to 2. It's never equal to 0. So for this equation to be equal to 0, I mean expression, this x cubed minus 1 should be equal to 0. So the solution of this equation is 1. And how about the last question, 2004, 2004, 2004? And we know that the sum of the first natural numbers, right? 1 plus 2 plus 3 plus dot dot plus n, that's equal to n times n plus 1 over 2. When we have more time, we can prove this. So suppose that that is equal to s. So S is equal to, the common denominator is 1 over 14, 1 over 2014 times, inside the bracket, we just have the sum of the first 2014 natural numbers, which is equal to 2014 times 1 plus 2014, that is 2015, and over 2 here. So now from here, these two things, it is gone. The answer is 2015 over 2. Okay. All right, guys. Thank you very much, Defna, Musa. And that sausage problem. And if you have some time and you have free time, you don't have to write anything. Just think, okay? How can we cut this? Now, also, I will think this. Also, it's a beautiful problem, okay? So I will meet you on Wednesday, guys. Thanks. And have a good night. See you on Wednesday, okay? Bye-bye.
Bye.
Thank you. Bye-bye.